Hi, welcome to xmTuition, where I help everyone with their physics homework. Like yesterday, I went to the downstairs provision store when this father asked me to explain this question to his daughter. So this question is about a point source that's emitting energy uniformly in all directions. And the wave that arrives at this point, 8 meters away from the point source, has an amplitude of A and intensity of I. So usually these kind of questions are testing you on these concepts. First, do you know that I is proportional to 1 over r squared? Meaning as the wave propagates, its intensity will drop. And how does it drop? It drops according to this inverse square law. So if the intensity follows the inverse square law, what about the amplitude? Since intensity is proportional to amplitude square, then if you square root this thing, you realize that the amplitude will also be dropping, but it will not be dropping according to the inverse square law. It's simply just inversely proportional r. Okay, let's go back to the question. The question says that the power of the point source is now halved. So instead of emitting energy at the rate of P, it's now emitting energy at the rate of P over 2. Because of this, the intensity of the wave when it arrives here will no longer be I. It will be I divided by 2, right? Because power and intensity are directly related. So if you halve the power of the source, then the power that arrives here will also be halved, and therefore the intensity will also be halved. But the amplitude will not be halved because intensity is proportional to A squared. If the intensity is divided by half, the amplitude is divided by root 2. So the question is asking, where's the point somewhere between here and here where the intensity of the wave is going to be I again? Do you think it's at the midpoint here? Consider this relationship here, yeah? If you halve the radius, the power will be 4 times. So if the intensity is I over 2 here, then the intensity here will be 4 times. So 4 times I over 2 is actually 2I. It's too strong here. So the position where the intensity is I is actually somewhere here. And for students who are very quick, straight away they'll know the answer is 8 divided by root 2. But let's do it slowly, yeah? So let's apply this relationship onto this point and this point. So at this point, the intensity is I over 2 and we can equate it to K over 8 meters squared. At this position, the intensity is I and we can equate it to K over the unknown x squared. Do the divide. Sure enough, x is 8 meters divided by root 2. So in this approach, basically we use the I is proportional to 1 over r squared relationship to solve everything. But let me show you another approach. In this approach, all we need to use is this relationship. Intensity is power per unit area. Because this is a point source, so all the power arrives on a spherical surface. And since intensity is power per unit area for a point source, the intensity is just power divided by the spherical area of 4 pi r squared. So originally, the intensity here would be P divided by 4 pi 8 squared. When we halve the power here, then at this position, x meters away, the intensity is P over 2 divided by 4 pi x squared. So we just need to equate these two intensities together, and sure enough, you see, x is 8 divided by root 2. So if you directly use the intensity is equals to P over 4 pi r squared for a point source, actually I think it's much easier, right? I hope this father will continue to encourage his daughter to study physics. I think he wants the daughter to become an engineer one day. Ta-ta!